Hello. Today we're going to start our study of Chapter 4 and look at polynomial functions. We've dealt with many types of functions before, like linear functions, or lines, or quadratic functions, or another word for parabolas. Right? And the key with lines and quadratics was a line had a highest power of x to the first, and a quadratic had the highest power of x squared. But polynomials are functions that have any highest power of x, right? It's unbounded. So we'd say a polynomial of degree n would look like this. Right? An example of a polynomial of degree 12 might be something like 11x to the 12th minus 3x to the 10th plus 4x squared minus 8. Right? Here the highest power of x is 12, so we'd say the degree is 12. Right? The key for any polynomial is our exponents have to be positive whole numbers, and our coefficients, the little a's here, have to be rational. A lot of what we want to do with polynomials is find where they cross the x-axis, or where our function f of x, or in this case p of x, is equal to 0. So what we say is a number r is what we call a root or a zero of some function p of x, a polynomial, provided p of r is equal to 0. So an easy example of something we've dealt with, like 4x minus 8 equals 0, we would say 2 is a root, because 4, if I plug in 2, 4 times 2 minus 8 is equal to 8 minus 8, which is 0, right? So 2 would be a root of that. But when we have polynomials with higher and higher exponents of x, that process becomes a little bit more difficult to find. So what we're going to need is we're going to need two new types of algorithms. One is what we call the polynomial division, which will very closely mirror good old-fashioned long division, and something we call synthetic division. And we will move on to examples of each of those. Okay, first we're going to look at polynomial division. And in polynomial division, it's actually a good analogy for the old division algorithm. So let's just see an old example of a division algorithm. So if we want to divide 1,562 by 7, we would set it up, right, just like this. And we would start looking and say, how many times does 7 go into 1? It doesn't, so we would X that spot out. How many times does it go into 15? We would say 2. We'd multiply and then subtract and drop the next piece down. We'd say, how many times does 7 go into 12? We'd say it goes in twice. We get 14. Subtract and get 2. We bring the 2 down. Say, how many times does 7 go into 22? We would say 3. 7 times 3 is 21, and we get 1. And once this number was smaller than our 7, we knew we could stop. So our answer would be 223, remainder 1, or once we got a little bit older, 223 and 1/7. Right? So now we can use this for an analogy for an example of polynomial division. Okay, here we want to do an example of polynomial long division. So we'll set up our x plus 2, 3x to the 4th, plus 2x cubed. One of the keys here is if we're missing any power, like an x squared, I want to include the 0x squared, minus x plus 5. And now what we're going to do is we're going to think about that x out there and that 3x to the 4th, and think, what would be missing if I wanted to multiply x and get to 3x to the 4th? Right? That answer would be 3x cubed. And what we want to do is think of each of these x powers as columns. Right? Which again is why we want to include this x squared, so we have that kind of column. Just like before, when we did our polynomial long division, when things fit, we put them in their separate columns. We're going to do similar things here. So we're going to multiply the 3x cubed by this x and 2. So I get 3x to the 4th plus 6x to the 3rd. And then we're going to do exactly what we did before, which was subtract. And when we subtract, we're going to want to switch the signs and combine. So this becomes 0. This is minus 4x to the 3rd plus 0x squared minus x plus 5. And we start the process all over again, right? If I start with x, how do I get to negative 4x to the 3rd? I need a negative 4x squared, right? Negative 4x to the 3rd, and then minus 8x squared when I multiply this negative 4x squared and this 2. Right? I want to switch my signs, right? That's the same as having that negative and subtracting, and I'll combine everything. So 8x squared minus x plus 5. And again, I do everything over again. I want an 8x, so when I multiply 8x by x, I get 8x squared. Here I'll get plus 16x. Let's see. Again, I want to change my signs, and I'll combine. That's negative 17x plus 5, and I get minus 17. So I get negative 17x minus 34. And so I'll switch my signs. I'll get 39. This is going to be my remainder. And so just like before, whenever we have a remainder, we want to put that number over what I'm dividing by at the end. So my final answer will be 3x to the 3rd minus 4x squared plus 8x minus 17 plus 39 over x plus 2. Synthetic division is a little bit different, right? Polynomial division will work for any two polynomials dividing. But when we use synthetic division, we want to see divide whatever our polynomial is by either an x plus r or an x minus r, right? It has to be an x to the first plus r and x to the first minus r. What we're going to do is if we have an x plus r, we're going to consider the negative r. And if I want to divide by an x minus r, I'm going to consider positive r. So for example, if I'm dividing by x plus 2, the number I want to think about is negative 2. And if I'm dividing by x minus 4, the number I want to think about is positive 4. And we'll see why in a second, right? And so the steps of synthetic division may seem weird, but it's actually an easier operation, right? What we're going to want to do is arrange the coefficients of our polynomial in descending order. So that means if I have something like 4x to the 7th minus 3x to the 6th plus 5x to the 4th, I want to arrange them like 4, negative 3, and 5. But what we also want to do, again, just like polynomial division, is not think of this like negative 4 or 4, negative 3, and 5. But if we're missing any spots, like we're missing an x to the 5th, I want to include that 0. So this would be the list of numbers I have. Right? What we're going to do is we're going to bring down the first coefficient. So we're going to bring it down and multiply it by r. We'll add this to the next coefficient. Then we're going to multiply that sum by r and add whatever that product is to the third coefficient. Right? So let's just see an example. All of that seems kind of confusing, but it's really much easier when we do an example of it. So I want to divide this polynomial by x plus 3. And remember what we said, when I have this x plus 3, the number I really want to think about is negative 3. So the way we set this up is we're going to take negative 3 and put it in a little box. And then we're going to list the coefficients of our polynomial. So 4. There is no x to the 4th term, so that's going to be 0. The x to the 3rd piece is negative 30. There is no x squared. Negative 50 for the x, and 12. What we're going to do is put a line with a little bit of space. So what we'll do is we'll drop down the 4, and we'll multiply this 3 and this 4 together. And what we'll do is we'll take that product and write it right under the next vertical spot. So negative 12. And then what we're going to do is add these two numbers together of 0 and negative 12 and get negative 12. Right. Then this negative 3 is going to multiply by this negative 12, and I'll get 36. And now I'll take that column and add it and get 6. Right? Now I'll take the 3 again and multiply and get negative 18. And I'll add 0 plus negative 18 is negative 18. Then I'll take the negative 3, multiply it by negative 18, and get positive 54. I'll add the negative 50 and the 54 and get positive 4. Then I'll take the 3, multiply it by the negative 4, or I'll take the negative 3 and multiply it by 4 and get a negative 12. I'll add them together and get a 0. And so how do we read this? So the last number is our remainder of the division. So if we recall from above, that remainder here was a negative 1. So in our example, that remainder is 0. So what this tells us is this divides perfectly, there is no remainder. So then how do we get the actual number that we want? Right? What we're going to do is fill in the x's from right to left. So this would be the x to the 0th, or the constant term. This would be what's multiplied by x to the first, x squared, x cubed, and x to the 4th. So our resulting polynomial, or our answer once we divide, is 4x to the 4th minus 12x cubed plus 6x squared minus 18x plus 4. And that would be our solution to this. One thing we want to be aware of is this theorem called the factor theorem. And so when we dealt with synthetic division, we said if I had something like x minus 2, I want to think about the number 2. Or if I had something like x plus 3, I want to think about a negative 3. So the question is, why are we switching these signs? And the answer is in our factor theorem. And so what this says is, if, for example, negative 3 is a 0 or a root, that the factor that corresponds to it is going to be x minus negative 3, or x plus 3. Or if x plus 3 is a factor, that automatically I know that the opposite, so negative 3, is my 0. So we have this opposite relationship between the x plus 3 being the factor and the negative 3 being the root, right? It's just like saying if x plus 3 is the factor, what makes that x plus 3 equal to 0? When I solve it, I have to subtract 3 over. That's where we get that inverse relationship. So when we're doing the synthetic division, what I want to do is not think about the plus 3, but think about what makes x plus 3 0. And an easy way to think about that is whatever I have here, I think about the opposite sign. So let's do one more example of each. We're going to solve this, divide 4x to the 4th minus 2x cubed plus 6x minus 1 by x plus 2 using polynomial division. Right? So what we're going to do is we're going to set this up, have our x plus 2 outside the division, and have the 4x to the 4th minus 2x cubed plus 0x squared. Right? I don't see an x squared in here. Plus 6x minus 1. And we'll start. We'll say, what do I need x squared to be multiplied to get 4x to the 4th? And that answer is 4x to the 3rd. So again, I want to think about these as columns. That's why I want that 0x squared if I have it. So when I multiply, I get 4x to the 4th plus 8x to the 3rd. And I want to switch my signs. minus, right? And I get negative 10x to the third plus 0x squared plus 6x minus 1. And I do this all over again. What do I multiply x by to get negative 10x to the third? That's negative 10x squared. And I write it right in the column for the x squareds. Negative 10x squared. Negative 10x squared times 2 is going to be negative 20x squared. Right? Again, I want to subtract, which is the same as switching my signs, and I'll bring everything combined. So this is 20x squared plus 6x minus 1. How do I get x to 20x squared? I multiply by 20x. 20x squared plus 40x, right? And I'm going to want to switch my signs. So minus, minus. I get negative 34x minus 1. And I'm going to multiply by negative 34. So I get negative 34x minus 68. I switch my signs, and I'll bring it down. I get 67. 67 has a smaller power of x to the 0th, than what we started with. So I have my answer. My answer is going to be 4x to the third minus 10x squared plus 20x minus 34 plus 67 over x plus 2. That's what I'm going to do with my remainder. Okay, let's do one last example. This one will be synthetic division. So I want to divide my polynomial by x minus 3. But when I think x minus 3, I think the number I want to put in my little box is a positive 3. And then I want to list the coefficients in decreasing order. So 8, negative 24, 1, negative 2, and 2. I draw my line, and again, I bring down my 8, and then I want to multiply. 8 by 3 is 24, and I want to add and get 0. 3 times 0 is 0, add 1 and get 1. 3 times 1 is 3, add to negative 2 and get 1. 3 times 1 is 3, add to 2 and get 5. That is my remainder. Again, so this is my remainder, this is my constant term, this is my x to the first term, x squared term, and x cubed term. So if I want to write my solution, it'll be 8x cubed plus x plus 1, and to deal with my remainder, it'll be plus 5 over x minus 3. And this would be my solution to the synthetic division problem. All right, thanks for listening, and I will see you in class.